Alright, so now it's time to practice writing net ionic equations and predicting solubility. Okay, so right now I have a very generic equation showed up here. Notice it's not balanced and it also doesn't have the states of matter. Okay, so if we were to look at this, first off we have to write down the states of matter that these things will be in. So we have, going back here, we have NH4 3 PO4. Now what state will that be in? Well, if we go back to look back at your solubility rules in your textbook, if you have not memorized them yet, you probably haven't. If you look, you'll see phosphates are generally insoluble. That means that they generally make solid substances when they're bonded ionically. However, ammonia, if you look at ammonia, anything bonded to ammonia is soluble. So this would be AQ. Then we have aluminum, aluminum 2, SO4 3. Now, if you look at your solubility rules, most sulfates are soluble. There are a few exceptions, but aluminum is not one of the cationic exceptions to make it insoluble. Okay, so we say AQ also. Plus, oh wait, and that goes to form AlPO4. Now the state that this one will be in, to predict that, we look and see phosphates are generally insoluble, and the exceptions are, one of the exceptions is not aluminum. So aluminum will not make phosphate soluble, a phosphate compound soluble, and so this one, or insoluble, no, soluble, so this one would be a solid. Plus, and then we have ammonia, and I just said that all ammonia compounds, ionic compounds, are soluble, so NH4 2SO4 AQ. Now we got to balance this sucker. So to balance it, and I'm just going to balance right below. Okay, if you look, we have 3 ammonias over here, only 2 over here. All right, the lowest common multiple of 2 and 3 is 6. So if we put a 2 here and a 3 there, we will have a total of 6 ammonias on both sides. Now looking at these other compounds, we now have phosphate ions. We have 2 phosphate ions here and only 1 over here. And we also have 2 aluminums over here and 1 over here. So if we put a 2 there, now our phosphates and aluminums are balanced. And if we look at our sulfates here, we have 3 sulfates here and 3 on this side as well. So our sulfates are balanced. So our chemical equation is 2, 1, of course, 2, and 3. So now we're balanced. We have a balanced chemical equation. All right, to write our complete ionic equation, we need to put all of these ions as they would be, in solution. So representing them as free ions in solution. For anything that's aqueous, it's broken apart. Anything that's solid stays together. So notice that if we have 2 here and 3 here, that'd be a total of 6 ammonium ions. So 6 NH4 plus AQ plus, and notice we have 2 of these, so 2PO4 3 minus AQ plus 2, see this 2 right here? That means there are 2 aluminums in the formula, so when it breaks it apart, it will break it apart into 2 Al3 plus AQ plus, and there are 3 SO4s, 3 SO4, 2 minus AQ, goes to form 2AlPO4 solid plus what's left over. We have this 3, 3 times 6, so it's 6NH4 plus 3 times, so 3SO4. Oh, there should be AQ here. AQ, SO4, 2 minus AQ. Alright, so now we start canceling things that have not changed. So these 6 ammonias haven't changed from left-hand side to the right-hand side, and these 3 sulfates haven't changed. So what's left over? We have 2PO4, 3 minus AQ, plus 2Al3 plus AQ, right there. Then that goes to form 2AlPO4 solid. So that's our net ionic. If we were asked what are our our spectator ions, we would say NH4 plus, and what else do we got? Oh yes, and SO4 2 minus. So these are spectators. So you might see some questions like this. So notice that you have to have the states of matter in all of your equations. You have to have it balanced, of course, and you have to break apart all of the aqueous things into their respective ions.